We are the Spartans.
How long have you guys been doing FLL, like each of you guys?
16 or so.
4 years.
1.
5.
1.
I've been doing it for 3 years.
3.
You guys show us your robot?
Yeah.
Is that a robot?
So why did you choose this particular design for your robot?
Well,
It has a frame so it can back up against walls and be straight, and it's more steady.
And
It's
since
lightweight and like reliable and versatile.
and you can put a lot of different attachments on it, so you can basically use the same body and attach different things to it, so it can do many different things.
such as attachments that we have here.
Mostly it's like last year's robot, so we didn't have to do much work on it.
The large wheels help it move faster.
Helps to make better turns as well.
Have you said you used it in the previous years. Was that like last year you used it?
Yes, we used this one
Yes,
last year.
it's same design.
Tell me what your robot is best at?
I think it would be
Moving
moving.
Yeah, thank you for the
Yeah.
specific answer.
long distances quickly.
Like it can turn easily.
Being able to do different things satisfactorily.
Yeah.
Yep.
It can turn easily. It can
Make
make
maybe nothing it
maneuvers
does
easily.
best, but everything it does
Because
very
of
well.
these wheels on the back, it helps to make better turns. Wheels on can go straight.
Gyro as well. Gyro sensor.
I feel like it can do a lot of things
Yeah, but
and
gyro.
can do all of them quite well, but
Yeah,
no one purpose.
Yeah, but gyro.
What your robot is not the best at?
I would have to say
Gyro.
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 Some-
It can be
it's like-
really
it's like-
good or horrible.
It's like one time.
It's like
1 minute it's at 0 when you put it up against the wall, and the second minute it's at minus 1065.
How did you deal with the unreliableness of the gyro?
calibrated.
Reset it.
Calibrate it,
Yeah.
just
If
keep
it doesn't
resetting
work, you
it.
reset it until it works.
Recalibrate, reset.
Overall, somehow it ends up working.
Yeah.
Somehow.
It's
Something.
Did you redesign your robot at any point?
yeah,
Like
we did.
multiple times.
We had this whole thing onto the top.
Lots of gears.
We didn't have the frame before on the original
Or the back.
design.
We got it. The
Or-
touch sensor.
Touch sensor, oh yeah, for program
sensor.
selection.
These wheels weren't on before.
To turn,
These are for turning against walls.
so you don't get jammed.
So can you show us your attachments?
Okay, so this one is pretty simple when you look at it. There's just a bar here that prevents these sticks from moving outward. So you can go over anything like we did here to grab the pig, and then we can back up and bring it back to base very easily.
It's just a simple arm. It can pick up one of these and put it down somewhere else. And this is so that it doesn't go like around back and get stuck here. And then this is so that we can control how low it goes. So we always set it up at the same position right here.
It's consistent.
So it's, yeah, it's reliable.
Yeah, apparently if you're, we noticed that if you're a bit off, then by the time you trying to accomplish your mission, things get weird because you've missed the fridge by a bit, or you've dropped the food off at the wrong place and it ends up blocking the robot later on. So this one is to align the robot against the wall like this, so it can push off and deliver this food like that. And where's the food? Oh yeah, this block is, it goes over here. So the robot, when it drives off to the fridge, it will always stay the same distance. And this is the shark block. It makes sure the shark is always the same distance away from the edge of the mat. So it helps control and make sure that the shark ends up in the target area each time.
So that's pretty interesting. So on your attachments, so what do you like about them and what do you not like about them?
The angle is too high up or too low, interferes with the mission too. Because you cannot run a mission when it's like this or like this.
You gotta have it perfect at angle.
So how have your attachments evolved over time? Because at the beginning,
Yes.
In the beginning, this used to be like this rack thing, and it was not sturdy. And
It would
broke easily, and it had a hard time latching onto the fridge. And sometimes the fridge would get like half open and be stuck like this, and then you couldn't close it again. So that would be like the end of your mission. So we have this. So the new version of the fridge, food, the claw to get food basically. It's more stable, and we have this bar over here to keep it stable, and to when you do this, it pushes the fridge door back in, so it doesn't get stuck and doesn't interfere with this.
Which attachment of yours was the most problematic?
I'd say this one because we just have to keep building onto it to get it to work. Every time we do it, and then we find more issues with it. So now there's still an issue. It can still go around back if it's at the right angle, and then it won't come off.
Oh yeah.
So we're just keep improving it, but then it ends up getting all bulky like this. So
There used to be a similar
yeah.
How do you drive a long way accurately? Like, can you show us how you oriented it?
So we use our
So we use light. So we have the bottom of the robot. We have
light
two
sensors.
color sensors or light sensors.
and they're used.
They detect the lines on the field, so we know exactly where we are.
Did you group any missions together in which the programs are?
We grouped a lot of missions together
Right.
in the last one, where you go over this, that's one mission, turn this, that's another mission, and you bring these here, that's a third mission.
How many sensors are on board your robot currently?
4. Yeah, 4. We have the 2 light sensors, a touch sensor right here, and a gyro sensor
Slow down.
right there.
So this is
Gyro
for
sensor.
rotation.
You have it really
Measures
fast.
turns.
And these are for finding lines, and this is the touch sensor, which is for selecting programs. Basically, we had an option of either running transfer or milking doggy mission as our sort of last program, and we have a program to select a program and use this.
We figured out that it was hard to scroll through all the programs to find the right one. So we made this one program where you just press your button. Each button sends a different program. So you just press the right button or the touch sensor depending on what your program is, and it runs your mission.
Such as pig bag for pig manure, which was what we did. That's you press the middle button for that one.
This way it's less likely that you'll either spend a lot of time looking for your program or you'll press the wrong one.
Yeah. Because no one wants to press the wrong one, set it up wrong.
Alright. Do you calibrate your light sensors?
No.
No.
We
Calibrate.
calibrate the gyro sensor.
Just
Because
the
they are
gyro.
unreliably
The
reliable.
light sensors are reliable.
Most of the time they detect color, not light intensity. And even when it's darker or brighter, the color doesn't change much. But even when it calculates lighting intensity, all it does is either make the robot a little faster, a little slower, but it's not enough to actually matter.
You have a huge team, so how do you split up responsibilities to work on different pieces?
So
Volunteering sometimes.
most of the time, we all work on like similar things. We made multiple copies of the robot, so we can test multiple things at the same time.
This is the
But
this
sometimes,
is Spartan robot.
even then, it got too crowded, so half the team worked on project while the other half worked on robot games.
This one was just a Sparta. We had Alan EDU robot, and Sparty Bot.
They're all the same.
They all look the same except for Alan EDU.
How often did you guys meet during the season?
Oh, we meet twice a week, Tuesdays and Saturdays.
Saturdays. I know my own name.
I know.
Creative shark placement.
By the way, these are low particular
Also known
matter,
as modern
so it's not. These are not the way that we do it.
And that's why we
Without
have the
those
wheels.
wheels, we wouldn't have like been able to turn like that.
That's why we have the wheels.
It's the thing. I call this.
No, it's-
We call this the one-way gate.
It used to go back.
It tracks in, but it doesn't hold. It doesn't then go out.
You're starting to. Normally that would be out of the way. So this is the food we just got from the refrigerator, and we're just feeding the animals with it.
Reliability.
So this one's going to run over to the gate, milk the cows, and bring both people to the training area.
This should work if everything is correct.
The manure is in the
Not
milk.
being unreliable.
I got this.
Yep. It actually was with this.
Oh, I'm sorry.
That's an
Is that a
accident.
reason why we do it after?
That's why, huh?
Is that an accident?
That can be a reason.
We do have.
We
one more
normally
line,
do it
but
after.
Let's take that into account.
Yeah.
Yeah, the 600
That went too far.
Yeah.